However, there are different types of answers that we can get here. Our first option is that our two lines do intersect, and they intersect at one point. So we'll get one answer. It'll be a point with an X and a Y. Our next option is, and these are two special kinds of lines, which is that the lines actually never intersect. Well, two lines that do not intersect are said to be parallel. And if that's the point of these systems of two equations with two variables is to find out where they intersect, and they don't intersect, it means that you won't actually have any answers. We'll have no solutions, no answers. The last option would be that if I were to draw my first line, suppose it's here, just draw right on top. And then I go to draw my second line right here, and they land right on top of one another. That means we are actually ending up with a case where they're intersecting infinitely many places. So we have infinitely many intersections. So we'll say infinitely many intersections or solutions, because they are the same line. It's one way of saying it also, is that they are the same line. Notice I'm being very careful to say that my answers are not all real numbers. The reason why I'm not saying that is because if I said all real numbers, I would be including points out here on the outside of my lines. Meanwhile, the only points where our graphs are intersecting are actually where the lines actually are on top of one another. So you can't just use all real numbers. You only want to include the points where our graphs are on top of one another, right along the line. And it keeps on going, so the points would keep on going too. The points where they are intersecting. Now, my math lab does usually like to write this answer a special way. Sometimes they'll ask you how many solutions, and you would say infinitely many. Sometimes they'll say, what does that mean about your graph? They are the same line. But they usually have a fancy way to say this, and they'll say basically that all of our solutions will look like the following, and they'll put it in set braces. We want all the points, all the X's and Y's. This line means such that, and then you'll put an equation of your line here. Technically, it doesn't matter which line you put there because they are the same line, but they usually like the one that's the smallest. There, that is when we are putting our answers into my math lab. So you're only going to use this kind of strange notation if they are the same line, if they completely land on top of one another. And we'll see what that looks like later. And again, what this means is you'll have your set braces, and what this means is you'll have all the points, X's and Y's, such that they're on the line, which makes sense. All the points that are on the line is where both lines are going to intersect. All those points that are on the line. So that's what that means, and it is a fancy answer. But yes, you do need to know that for my math lab, because your homework's on my math lab, your tests are on my math lab, and your final exam will have answers like that as well. Here's another one. So in this next set of examples, what we're going to try is actually doing these by hand, though. We're going to learn two different tactics for solving these systems of equations without graphing them. And the first one we're going to learn is what's called substitution. And what substitution says is pick one of the two equations, doesn't matter which, to start with, and get one of the variables alone. So if I look at problem A, which of the two equations is easy to get one of the variables by itself? And I'd say that that would be the first equation. The 4x plus y equals 5. So what we'll do is we will solve the equation for the easiest thing we can, which is the y. So how do I solve this equation for y? Well, the quickest way is to just go ahead and subtract the 4x from both sides. And what that gets me is that y equals negative 4x plus 5. Notice I have been numbering my equations as I go along. That makes my life quite a bit easier. Now the question is, what do I do with this? This is why I number my equations, is now I'm going to take what I just came up with for y and plug it into the other equation I haven't used wherever there's a y. So let's copy our equation down that we haven't used. The 2x minus 3y equals 13. And what we'll do is we'll replace that y with what we found in our first step. So we've got our 2x minus 3 that will all stay the same. But we're going to replace that y with what we found, which is that y can be replaced with negative 4x plus 5. Remember, just like in the last couple sections, if you plug anything in, make any replacements, you've got to put parentheses around whatever it is you're plugging in. And the other side hasn't changed. It's still a 13. So now all I have to do is work on how to solve this equation. Well, the first thing I need to do is get rid of those parentheses, and to do that I need to distribute the negative 3. Well, the 2x that was first, though, won't change, but distributing that negative 3 will get us a positive 12x, because we've got a negative 3 times a negative 4x. And then the last part is a negative 3 times a positive 5, which will give us a negative 15. And this all equals 13. So what do we do next? We've got a 2x plus a 12x equals, and that gives us 14x when we combine our like terms. And we can combine our like terms because they're on the same side of the equation. Then we've got a minus 15 equals 13. Now what? Well, now I need to get the x by itself. Continue solving the same way you would normally. So we'll add 15 to both sides. And that will give us that 14x equals 28. Last step would be that we're going to divide both sides by 14. And that gets us that x equals 2. Be careful, we are not done. This is only half of the answer. Remember, your answer, if you're getting one, should be a point, meaning an x and a y. We just found the x. We still need to find the y. So how do we find the y using our x? Well, we're going to take our x that we just found from our second part and plug it back in to the first part, wherever there's an x. So we're going to replace that x with a 2. Technically, you can plug it into any equation. It doesn't matter because they'll both pass through this point, but this is just the easiest. So you'll get the negative 4 times 2, which is negative 8, plus 5 is negative 3, and that is your y value, negative 3. So your final answer is the point 2, comma, negative 3. Now let's take a look